So therefore, now that we understand how to find the mean deviation of this kind of table and for group data, since I've already explained that, then we can go ahead and continue with okay, the next one, which is the third one. After mean absolute division, that is when we have what we call the variance itself. How do we find variance? Variance is always equals to the summation of f. Instead of taking absolute, we don't need that. Just take x minus x bar. But you have to, the difference between this formula and this one is that this one you just have to square. Just square it over summation f. That's all. And there's no absolute. You know, when you square, even though you have a negative outside, it becomes positive. This is for group data, okay? But for group data, we always have this formula. Summation. It will not have frequency, you know. If it is group data, you have frequency. If it's not group data, you don't have frequency. That's just x minus x bar. Then you square it over summation f. So calculator will also do that for you, okay? But if you want to solve it by hand using that same 2, 4, 6, 8, this is the mean, right? So to find the variance, that will just be x minus mean 2. That will be take 2 minus the mean is 5, abi, then you square it. That's what variance is all about. Instead of taking the absolute, after subtracting, you square it. That's just the variance. And then 4 minus 5 square, 6 minus 5 square, then 8 minus 5 square. I believe you understand this. Over n, not summation f, number of items. How many are they? 1, 2, 3, 4 over 4. So then you can just use your calculator to press that. Remove this thing from statistics mode. That's press mode and 1, computer mode. Then you go ahead and press 1. Okay, then you need this box over box button. We need this box over box button, and then I'll begin to put all these values. Open a bracket, then I have 2 minus the mean square plus, open another bracket, 4 minus the mean squared plus, open another bracket, 6 minus the mean squared plus 8 minus the mean squared over number of items 4. So this variance is what? Is 5. Now since the variance is 5, now how do you find standard deviation? Take note, standard deviation is always square root of variance. That's all. So square root of that, square root of what? Square root of 5, and that's 2.2 something, 2.23 or so. Square root of 5 is what? Is 2.24, 236. As you can see, that's 2.24. Okay, but what if I don't want to solve it by hand? That means you press mode in a very fast way. Then you can see start on number 3. I want this to get clear. 3. Then you cut it away, press AC, shift and 1, data. I don't need frequency. Let me switch it off. Shift and mode, come down, start 4, switch it off. Okay, 2, 4, 6, 8. Shift and 1, VAR 4. Then you go ahead and use 3. 3 is standard deviation. You can only get standard deviation. Standard deviation is what? 2.23. To get variance, just press square. This answer, square it. So variance is 5. So calculator works all the time for this kind of questions. So you don't have to stress yourself. And take note, variance is always the second moment about the mean. Take note, please. Variance is always what? The second moment about the what? The mean. Is that not true? The deviation you have, this data now deviates from mean itself, right? So whatever you have on as the degree for this deviation is what we call the second moment. If you have 2 here, you call it second moment. If you have 3 on this place, you call it third moment. Okay, if you have 4 on it, you call it fourth moment. So that's just what it means. Okay, so I've explained range, mean absolute deviation, variance, and standard deviation. The next video will be based on, after explaining this, then I think the last one is what we call the fractals. The fractals and the what? The fractals, so you call it what? The quantiles. You have what called the fractals or the quantiles. Fractals or quantiles divides a distribution into equal parts. Okay, Now let me give you a very brief explanation on that. Now I said we have what we call the fractals. These fractals or quantals, not quartiles, they divide the distribution into equal parts such that we can divide that distribution. The most common one we use most of the time is we use quartiles. The second one is we always use what we call the deciles. We can divide it into 10 equal parts. And then the last one is what we call the percentiles. Take note of that. So you see these quartiles, we have 3 of them, which is we have the lower quartile, we have the middle quartile, and we have the upper quartile. But this one we have 9 of them. We have the lower decile, we have the middle decile, and we have the upper decile. That is from D1 to D9. From D1 to D9. And then this percentile, you always have the lower, which is P10, and we have the upper, which is P90. So we have P10, P15, or P20. We make use of P10, P20 all the time. P10, P20, P25, P30, like that. Okay. So now, what is the main general formula for these quartiles? The main formula is that you always have QI. This is the pattern. Remember the formula for median. That's what you just follow here. QI is always equals to Li plus, you open a big bracket, IN over, when you are dealing with quartile divide the distribution into 4 equal parts. That's over 4 minus CFB over F times C. You remember this formula now? That's how it works. And for deciles, it will be DI is equals to Li plus IN over, so decile divide the distribution into how many equal parts? 10 equal parts. So they are using the same formula, no difference, over F times C. This percentile too will be what? Pi. What's Pi? Pi is Li plus IN over 100 minus CFB over F times C. Now, what if you want to look for Q1? Q1 now means that you have L1, okay, plus 1n over 4, which is still n over 4, minus CFB over F times C. Do you understand that? So that's how it works. So you do the same thing the way you did median. That's how you're going to solve this one. Just take n over 4, find the position, look for the position from the cumulative frequency table, and then locate your lower class boundary for it, and locate the cumulative frequency before it, the frequency and the class width. That's all. And then I noticed one thing too. What of D1? D1 is L1 plus 1n over 10 minus CFB over F times C. Okay, do you understand? That's how it works. So just take n over 10, find the position for the decile, for the D1, the first decile, and then locate your position, and then find the lower, find the CFB, the same process. But there are some relationship that exists between these things. Do you know that if I find Q2, this Q2 is also known as what? Middle quartile. It's also known as median rather. We call it middle quartile, right? We call this one middle decile. This is also median. Median, okay? P50, which is the middle, P50 is also what? Is also median. So therefore, it is clearly seen that Q2 is always equals to what? D5 is always equals to what? P50, and is always equals to what? Median. So take note of this. So how can I easily detect this? Instead of it writing out all the formulas, so if you ask that which of the following is correct, so this is correct. Do you know why? Q2 means you are expected to have 2n over 4, yes or no? If you have Q2, L2, 2n over 4, 2 cancel, you see, this is that. And D5 means you are supposed to have 5, D5, IN over 10, 5n over 10, okay? And P50 means you are supposed to have 50n, where I is 50, right? 50n over 100. So by the time you cut this, you have n over 2. By the time you cut this, you still have n over 2. By the time you cut this, you still have what? N over 2. 50 here 1, 50 here 2. So remember that for median, the formula for median that I gave you from the previous video, it was n over 2 we use. Okay? It was n over 2. Median owns that n over 2, which everything becomes the same. In fact, the L2 or L1 still remain the same with the normal L that we have here. So trivially, we can easily say that Q2 is equals to D5 is equals to P50. So that's how to sort out all those quartiles, deciles, and percentiles. So just when you understand median, you'll be able to solve this. So there's nothing really special about it. What if I ask you what is P? Let's say you are trying to look for D4. What was D4? D4 will be 4n over what? Over 10 deciles. Okay, and that's 2 year 2, 2 year 5, and that's 2n over 5. Now, do you know that we can still have another thing that will give us this 2 over 5 from this P50, maybe P75. Let's find P75. P75 is 75n over 100. And what's 75 over 100? That's 3 over 4. Okay, that one is 3n over 4. There's another one that can give us that kind of stuff. Okay, so that is how it works. These are not the same, but we have some other ones that are the same apart from this median definition. So that's all on measure of what? Dispersion. So the only topic we have left is to talk about measure of skewness and measure of what? Kurtosis. So thank you. I believe you understand this. But before I move straight to this next topic, I would like to solve some questions. Okay, like I'll just give you a very brief explanation on this. Can you see measure of dispersion? We talk about range, highest minus lowest. We talk about mean deviation. I gave you the formula. Find the mean and median. I've explained that. You are given this kind of data, calculate the mean deviation. You know what to do. Looking at this set of data, find the class mark of everything. Let me ask you one thing. From this class interval, is it closed or open? It is an open interval. So since I'm looking for the mean deviation, I don't need class boundary or anything. It's only when I'm looking for median, that's when this thing has to be closed, median and mode. So for mean deviation, just find the class mark, then find the mean, and then from there deviate it. Find the mean. Do you see? Their mean is what? The mean gave us, they got mean as 66.40. So everything is there. Now you deviate it 66.40. Take each of the datas. When you pick class mark is 61. Add it divided by 2, you have 61. 61 minus this is the result, minus this. So take the absolute, you have positive sign. Multiply it by the frequency. This times the frequency will give us all these values to get 296.4. So that's how it works. And then sum it, you have 296.4. When you sum all these results, you have 296.4. So I believe you all understand how to find mean deviation. That was very, very direct. For variance too, see the variance, this formula for variance, just square it and divide by n. Standard deviation is square root of variance. So to find this, I can easily find this. I've not checked the next page. Let's use calculator to solve this. Straight up. So you have 23, shift and 1, data. Go for data. Data is number 2. Since data is number 2, then you put in the datas. If I put in the datas, I have 23, I have 20, shift and 1 data, I have 23 equal to 20 equal to 18. Can you see those data? 24, 27, is that all? We have 34, we have 30, and we also have the last one to be what? To be 34. Now since we have this now, press equal to. So that's all. Since I've pressed all these, I've input all these values into this calculator. So the next thing for us to do is to press shift and 1. But before you do that, not yet, press AC. Hey, I believe the data is still there. Shift and 1, data is still there. Shift and 1, then you go ahead and press VAR. This is standard deviation, okay? This is my final answer for standard deviation. But the answer for variance is now square. Just square it. Variance is 32.18. So let's confirm. Variance is what? For this question, it's not correlating. Then that means there's something wrong somewhere. So let's check. Maybe there's mistake in their own computation. But let's just check our data again. 23, 20, 18. Okay, I've seen my mistake. 23, 20, 18. There's no mistake. 24, this 27, this 34, this 30, and this 34. That means there is mistake in their computation. You can try to go through that, okay? Just check. Deviation, there is mistake. I'm very sure the correct answer to that question should be, I want to find the mean first. So So to consider what they use. So the mean is 26.25. Let's check. It is not stated. The mean is 26.25. Now the problem now is they said the mean is 25. That is where they made mistake. The mean is not 25. Okay, I don't know why this is not clear what happened. That's where they made mistake. They said the mean is 25, and which is not. Calculator says the mean is what? 26.25. So that's where the mistake is coming from. So it's better for you to use calculator most of the time to just get the straight answer. This is another formula for variance. You can just take each of the if you want to avoid if you want to avoid looking for mean all the time, just square the data given to you, square the class mark. These are the class marks, the x. When you square them, you have all these results. Sum all these squares together, you get this answer. When you sum all the squares, you have 5190. Okay, then sum x, you have 200. So divide it by n and square this result, and then divide this one by n, subtract it to get the final answer. So that's just what that one is trying to tell us. But still, I've not got it to where I'm going to. Measure of dispersion. Okay, we have all these formulas. Take note of these formulas. That is if we are looking for relative measure of dispersion. That's when we talk about coefficient of spread. That's spread over center. Take note of this formula too. This is formula for quartile deviation. Quartile deviation is also known as semi-interquartile range. Take note. Percentile deviation is what? P90 upper minus lower over 2. Take note. Okay. Upper limits, upper percentiles, P90. You know how to find P90 now. P90 is known as P90 is equals to L90 plus 90N over 100 minus CFB over F times C. And I believe you can compute that. So this coefficient of mean deviation is mean deviation over X bar. I believe you can find mean deviation of any data. You can find the mean, so divide it. Coefficient of quartile deviation means find the upper quartile. You know how to do that. That's L3 plus open bracket 3n over 4 minus CAB over F times C. Find the upper quartile minus find the lower quartile. This is Q3 minus Q1 over Q3 plus Q2. Or if you know how to do it that way, just find quartile deviation. Go and find your semi-interquartile range, and then you divide it by the what? By the arithmetic mean. And then we also have coefficient of standard deviation. Coefficient of standard deviation simply implies that just find the standard deviation of that data and then divide it by the mean. That's all. And coefficient of variation means find the standard deviation, divide it by the mean, and multiply it by 100%. So you have to cram all these formulas. You must know them. It is very, very important. Okay. So these exercises here, we have an exercise here, and then we also have this. So compute and interpret the sample standard deviation. Now we are dealing with sample standard deviation. Now this is how to find it. When you press, it's still on statistics mode, shift and 1, data, and clear data. Now considering this, now I have to put in all these values. So when I put in all these values, I have 5.5. okay, I have 10.6, and I also have 19.0, 24.5. I'm not pressing the correct thing. 5.5, 10.6, 19.0, 24.5, and then we have 24.5, we have 6.6, 26.8, we have 6.2 minus 2.4 minus 28.3, 2.3. So that's all. And I want to find sample standard deviation. That's very direct. Just press AC, shift and 1, VAR. This is sample standard deviation. That's number 4. Sample standard deviation is 15.68. That is, you're using that same formula, that same summation, f of x minus x bar squared over, instead of using over n, you are going to use over n minus 1. That is what it means. Okay, then they say you should calculate the coefficient of variation. Coefficient of variation, see the formula here, SD over mean. So the SD is 15.68. Take note of that. What is the mean? Shift and 1, data, okay, sorry, shift and 1, let's find the mean, VAR, see the mean, that's on number 2. So I have 2 as the mean. When I press equal to, the final answer is what? 7.08. So therefore, coefficient of variation is the previous result I got for sample standard deviation is 15.68. 15.68 over the value for your mean, put it here, and then you multiply it by what? By 100%. So that's all. So that's how to get the coefficient of what? Of variation. So I'm trying to look for questions on quartiles and deciles, which is not here. Maybe it's in another exercise. To find semi-meter quartile is very direct. Just find Q3 minus Q1 over 2. But I will advise you to work with past questions rather than you working with all these theoretical questions. Okay, so that's how it works for everything. So I've seen them here. Given this data now, this thing is not bounded, so I have to find the class boundary. This one will be 0.5, this one will be 9.5, 9.5 to 19.5, 19.5 to 29.5, like that. Find the CF, cumulative frequency, 4, 14, then like that. Then prepare a cumulative frequency table. That's it. I've just said it now. Use your table to draw and no give curve. Since you are not doing theory part, so you are considering the objective part of it. So you are not asked to draw in your exam. And then use your O give to estimate. Okay, but what if you solve it by your hand? You can still solve this by your hand by saying key 1 is the lower quartile. Find the position of the lower quartile, that is n over 4. If it falls here, if lower quartile falls here, let's say it falls here now, then the lower class boundary will be what? 19.5. So what is the class size of this thing? The class size is what? The class size of this thing is 9. Is that you do 20 minus this is the lower minus this lower? Okay, sorry, it is 10. 20 minus 10 is 10. Or I pick upper minus upper. 29 minus 19 is 10. That is 10. Please take note. You have 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. That's 10. The class size is 10. Take note. Okay? Or you subtract, or you do upper class boundary minus lower class boundary. So we know that already. If this is the position, I'm just saying, then the CFB will be 10. The frequency, the CFB will be down here, but the frequency will be 15. So do you understand? So you get the position from cumulative frequency from what you have down here. So to find the quartile range is simple. P10 and P90 is simple. 88 percentile, that's L80 plus 80n over 100, like that. Find the quartile and percentile coefficient of skewness. The formula is here. In this case, is there. And percentile for coefficient. So just take note of each of them. So our next topic is based on measure of skewness and kurtosis. So thank you very much.